Sometimes for a given mechanism we will be interested to know the extreme positions of the links. Okay, so in this video what we are going to do is we are going to see how to identify those extreme positions. Okay, let's say we have a crank rocker mechanism. Okay, so we have a crank rocker mechanism. Let's say this is the crank rocker mechanism, and say this is link 1 2 3 4. Okay, and this point is A, this point is B, and say the link 2 will have a complete rotation and link 4 is going to oscillate. Okay, and let's say it's going to oscillate between this position and this position. So those are the two extreme positions. Okay, so let's say this point is BR to represent the right extreme, and this is BL, the left extreme. Okay, the right extreme, the left extreme. Now we need to identify this BR and BL, so that I will get to know the range of motion of the that particular link, and yeah, so for that reason I will be interested to know the extreme positions. Let's see how to identify this. Okay, first let's say if I construct, so for this case what we will know is L1, L2, L3 and L4. We know only these four variables, okay, the link length, but we do not know theta, because once we define theta we know single configuration, but the extreme positions are two different configurations. Okay, so we need to identify this theta r and theta, okay, this is theta 2, as I already mentioned, it's theta 2 r and theta 2 L. Okay, and what is this theta for these extreme positions, and also I need to know what is BR, BL. So those are the main things which I need to know. Okay, so let's see how to identify. So say for some theta, okay, so for some arbitrarily chosen theta I can construct my 4-bar link mechanism. Right now if you see this BR and BL is going to be somewhere in the circle, okay, with, okay, this is O2 and this is O4, with O4 as a center, okay, and L4 as the radius. Okay, O4 as a center and L4 as a radius, I will get this circle. Okay, and this BR and BL are going to be in this circle. Okay, now when do I achieve my BR? I will achieve my BR when this link 2 and link 3 are collinear. Okay, so when these things are collinear, which means this angle, okay, is 180 degree, then I will achieve one extreme position, and that extreme position will be BR. Okay, so in order to identify the position BR, what I should do is I have to draw a circular arc. Okay, the circular arc with O2 as a center, okay, and the radius is going to be L2 plus L3, okay. So let's say this is the L2 plus L3, and maybe that's the point, okay. So because of that time, this is going to be something like this. So that's my link 2 and that's my link 3, okay. And what about BL? Again the BL is going to be in this circle, okay, in this circle, but at which point? Even at that time, this angle, okay, this angle, let's call that angle as psi, okay, that angle has to be 0 for the other extreme position. If that has to be 0, then how can I identify that point BL? I can identify that by choosing once again O2 as the center and radius R as L3 minus L2, okay. So L3 minus L2, and if I do that, I will get one more circle, and this is the BL, okay. Let me change the color to represent the two extreme positions. So one is this position, okay, another one is this position, okay. In this position we will have one solution like this, and here we will have a solution where this is link 2, and from here that's link 3. So this is our BR and that's our BL, okay. So yeah, we have identified the position BR and BL. Maybe we will also be interested to know what is theta 2 when B reaches BR. That's theta 2R. For that, all we have to do is we can measure the angle. So that's theta 2R, and the angle between this and this, that's theta 2L, okay. So like that we can identify theta 2R and theta 2L. Okay, let's see the same extreme position for a slider crank mechanism. So okay, so that's a slider crank mechanism. Let's call this as O2, A and B, okay. Now the problem will be like L2 is given, L3 is given, and E is given, okay. Now what we require is, once again, BR, BL and theta 2R, or theta, we were just mentioning it as theta, right? So that's theta, theta R, theta L. These are the things we need to know, okay. So what we should do, Okay, let's now construct this configuration for some arbitrary theta. So this we have constructed using these data and some arbitrary theta. Okay, now once again, for extreme case, the psi has to be 180. For one case, the psi has to be 180. For the other case, the psi has to be 0. If psi has to be 180, then the extreme position, in order to identify the extreme position, the BR, we need to draw a circle with this O2 as the center, and radius is L2 plus L3. Okay, so if I do that, I'll get some circle, and that's our BR. And similarly, if I draw a circle with O2 as a center and radius L3 minus L2, okay, and that will give me one more circle, which is this, which intersects this line is this. So we will have two extreme positions. One is here, so that time it's going to be something like this, and the other thing is going to be like this. So this is BR and that's BL, okay, and this angle is theta R. Actually this angle should be theta L. I think I have made a mistake earlier, not this angle, but so this angle should be theta 2L. Okay, so that's how we identify these extreme positions. Okay, thank you.